1, 2, 3, 4. Sokotoa, sokotoa, sokatoa. 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 Sign, opposite hypotenuse sign. Opposite hypotenuse sign. Opposite hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse tangent. Opposite adjacent tangent. Opposite adjacent tangent. Opposite adjacent. The long sides of hypotenuse and the other two sides depend on which angle you're focusing on. Pick one angle and look. There's one side that's the opposite. You can clearly see that there's also an adjacent side. Sine, opposite hypotenuse sine. Opposite hypotenuse sine. Opposite hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse tangent. Opposite adjacent tangent. Opposite adjacent tangent. Opposite adjacent. Sokotoa, sokotoa, sokatoa. 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 Sokotoa, sokotoa, sokatoa.
So if you haven't guessed, we're going to be working with SOHCAHTOA. And SOHCAHTOA is a little reminder of the ratio of sides for the trig functions. Now you're probably familiar with SOHCAHTOA, and you probably realize that what that stands for is sine is the ratio of the opposite side divided by the hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse. And tangent is the ratio of the opposite over the adjacent. Now what might be new for you are there three reciprocal trig functions. We have cosecant, which we use the abbreviated letters CSC, and that is just the opposite of sine. It's the ratio of the hypotenuse over the opposite. We then have secant, or SEC, and that's the opposite of cosine. It's hypotenuse over adjacent. And then we have the reciprocal of tangent called cotangent, and we use the letters COT. And don't call it cot, it's cotangent. And that's the ratio of the adjacent side over the opposite. So mostly everything is a review here except for the three new trig functions, which are just the reciprocals of the three you already know. So in this example 1, we have a triangle here, and we want to list all 6 trig functions. We want to list the ratio of the sine, the cosine, the tangent, and then the other 3 reciprocals, cosecant, secant, and cotangent. For us to list the ratios of the 6 sides, we need the ratio of the 6 trig functions, we need all 3 sides. We have, here's the angle. That makes the 12 the opposite side. The 5 would then be the adjacent. We're missing the hypotenuse. So how can we find the missing side of a right triangle? You can use the Pythagorean theorem. A squared plus b squared equals c squared. So the adjacent side, 5, and the opposite side, 12. So 5 squared plus 12 squared will equal the hypotenuse squared. Or 25 plus 144 will equal c squared, or c squared will equal 169, or c will equal 13. So the hypotenuse is 13. Now that you have all 3 sides, we can list the ratios. Sine is the opposite, or 12, over the hypotenuse, 13. Cosine, adjacent over hypotenuse. Tangent, opposite over hypotenuse. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. I messed up on tangent. Tangent was opposite over adjacent. That should have been a 5. Now in example 2, we again want all 6 trig functions. This time they actually give us one. So again, we're going to list all 6. Notice they give us the sine, so at least fill that one in. We know we got that one right. And you can even fill in cosecant. Cosecant is just sine flipped over, so that's 7/4. Now we need to find the other 4. What we need to do is draw our own right triangle. Label one of the smaller acute angles. So I'm going to label this bottom one. You could have done the top one. Now if I label this bottom one, that means this side is the opposite. This bottom one here is the adjacent, and we obviously know this is the hypotenuse. Now they gave us sine. Now remember, because of SOHCAHTOA, sine is telling us the opposite over the hypotenuse. So now label that. The opposite is 4, the hypotenuse is 7. So we're missing the adjacent side. So how can we find the missing side of the right triangle? Again, we're going to do Pythagorean theorem. A squared plus b squared equals c squared. So we can plug in 4 squared plus b squared equals the hypotenuse squared. After solving for the missing side, I don't get an exact integer answer. I actually get the square root of 33. So I'm going to leave it square root of 33. I'm not going to make it a decimal. So that is the adjacent side. So now I can fill in the other functions. Cosine is the adjacent, which is radical 33, over the hypotenuse 7. Tangent is the opposite, 4 over radical 33. Now, if you remember from geometry, we're not allowed to keep radicals in the denominator. So what you're going to do is rationalize. You're going to multiply the numerator and denominator by that radical. And that now gives me 4 radical 33 over a regular 33. Secant is hypotenuse over adjacent. We have a radical in the denominator again. Multiply by that radical top and bottom, and we'll get a final answer of 7 radical 33 over a regular 33. Cotangent is adjacent over opposite. We'll try the monitoring progress in class.